Question 1. Considering the evidence, Mr. Adams is retrofitting an old commercial HVAC system to improve energy efficiency without major structural changes. He must decide between upgrading to a system or adding demand-controlled ventilation. Which approach best balances energy savings and occupant comfort? A. Upgrade to ERF system only. B. Implement demand-controlled ventilation only. C. Combine both ERF and demand-controlled ventilation. D. Replace existing equipment with standard efficiency units. Answer. Correct answer. C. Explanation. Combine ERF systems with demand-controlled ventilation maximizes energy efficiency and occupant comfort by allowing precise zone temperature control and modulating fresh air based on occupancy. ERF systems adjust refrigerant flow to match loads, reducing energy waste, while demand-controlled ventilation reduces ventilation energy by responding to co-levels. Choosing either alone sacrifices benefit. ERF alone may overventilate, and ventilation alone doesn't improve temperature control or system efficiency. Replacing with standard units wastes energy and misses opportunities for improved ECN savings. Question 2. From a practical standpoint, is Rivera's analyzing refrigerant options for a new HVAC system aiming to minimize environmental impact while maintaining system performance? Which refrigerant property is most critical to evaluate for sustainability? A. Ozone depletion potential, or B. Thermal conductivity, C. Global warming potential, D. Boiling point. Answer. Correct answer. A. Explanation. Ozone depletion potential directly affects stratospheric ozone and is a key environmental concern regulated by international agreements such as the Montreal Protocol. While global warming potential is important, minimizing ozone damage has historically driven sustainable refrigerant selection. Thermal conductivity and boiling point affect system design, but have less impact on environmental sustainability. Choosing refrigerants with zero or near zero ODP ensures compliance and mitigates damage to the ozone layer, a foundational principle in refrigerant management. Question 3. In the modern context of HVACR operations, Istagang notices his heat pump system's performance degrading despite regular maintenance. What is the best next step to identify the root cause? A. Replace the entire heat pump system. B. Conduct performance monitoring using system data logs. C. Increase refrigerant charge without testing. D. Schedule emergency repair without diagnosis. Answer. Correct answer. B. Explanation. Performance monitoring through data logs allows detailed diagnosis of issues such as reduced capacity, inefficiencies, or sensor faults, enabling targeted repairs and avoiding unnecessary replacements. Increasing refrigerant without testing risks overcharging, causing damage or inefficiency. Replacing the entire system prematurely wastes resources and energy. Emergency repairs without diagnosis lack informed intervention. Approach reflects best practices in troubleshooting high-efficiency systems by leveraging data-driven decision-making. Question 4. Given the circumstances, Isa Patel is designing ductwork for a new green commercial building aiming for LEED certification. Which duct design principle will most significantly improve energy efficiency? A. Using oversized ducts to minimize pressure loss. B. Minimizing duct length and avoiding sharp bends. C. Selecting materials with the highest thermal insulation only. D. Placing ducts in unconditioned spaces to save construction costs. Answer. Correct answer. A. Explanation. Oversized ducts reduce air velocity and friction losses, decreasing fan energy consumption and pressure drop. However, oversizing must be balanced to avoid excessive material use or space consumption. Minimizing duct length and bends helps but is secondary to sizing for airflow. While insulation reduces heat loss, the primary energy waste from ducts is pressure loss. Placing ducts in unconditioned spaces can increase the losses, reducing system efficiency, contradicting sustainable design goals. Question 5. Through the lens of energy auditing, Mr. Thompson evaluates an existing HVAC system with unusually high energy consumption. Which of the following would most likely explain the inefficiency? A. Excessive refrigerant charge. B. Lack of preventive maintenance on air filters. C. Incorrect load calculation during system design. D. Using variable speed compressors. Answer. Correct answer. C. Explanation. Incorrect load calculation leads to oversized or undersized equipment, causing short cycling or inability to meet demands efficiently, increasing energy consumption. Excessive refrigerant charge can cause minor inefficiencies, but rarely alone causes major consumption spikes. Lack of air filter maintenance impacts airflow and indoor air quality, but is typically less impactful than fundamental sizing errors. Variable compressors generally improve efficiency, not reduce it, by matching capacity to load. Question 6. Under the assumption that ISNUN wants to reduce refrigerant leaks and environmental impact in her facility, which refrigerant handling best practice should she prioritize? A. Using an HEFC refrigerants for ease of handling. B. Ensuring proper refrigerant recovery and recycling procedures. C. Venting refrigerants when repairing leaks. D. Ignoring small leaks to reduce downtime. Answer. Correct answer. B. Explanation. Proper refrigerant recovery and recycling prevent emissions of harmful substances, aligning with EPA regulations and environmental stewardship principle. HECS have high up being phased out, so using them contradicts green practices. Venting refrigerants is illegal and environmentally damaging. Ignoring leaks increases cumulative emissions and system inefficiency. Prioritizing correct protects the environment and ensures compliance with regulations. Question 7. While examining ventilation strategies, Mr. Lopez must select between heat recovery ventilation HRV and energy recovery ventilation for a humid climate. Which system provides the greatest overall indoor environmental quality and energy savings in this context? A. Heat recovery ventilation HRV. B. Energy recovery ventilation C. Natural ventilation only. D. Mechanical ventilation without recovery. Answer. Correct answer. B. Explanation. Systems transfer both sensible heat and moisture, reducing cooling loads and maintaining indoor humidity levels. In humid climates, improving EC and energy saving HRVs only transfer heat, which can increase humidity indoors. In humid areas, reducing comfort and system efficiency. Natural ventilation lacks control and filtration, making it unreliable for EC. Mechanical ventilation without wastes energy by conditioning 100% fresh air without reclaiming heat or moisture, increasing costs. Question 8. In the framework of green certifications, HVACR wants to maximize their building's Energy Star rating. Which HVACR strategy will most directly contribute to achieving this certification? A. Installing the minimum co-compliant equipment. B. Incorporating advanced controls for load matching and scheduling. C. Using traditional fixed-speed equipment for reliability. D. Reducing system maintenance frequency to save operational costs. Answer. Correct answer. A. Explanation. Installing minimum code-compliant equipment may meet basic standards but rarely maximizes Energy Star ratings, which require high efficiency. Advanced controls optimize performance by matching load, reducing energy use, and enhancing occupant comfort. Key factors for Energy Star. Fixed-speed equipment is generally less efficient and flexible than variable speed, reducing maintenance risk, system degradation. Efficiency. Counterproductive to certification goals. Question 9. A key distinction between refrigerants is their environmental impact. Mr. Kim must explain why natural refrigerants are preferred over synthetic ones despite some system design challenges. Which explanation best captures this reasoning? A. Natural refrigerants have zero global warming potential and zero ozone depletion potential. B. Natural refrigerants are easier to handle and require no safety precautions. C. Synthetic refrigerants are always more efficient than natural refrigerants. D. Natural refrigerants are less available and more expensive, so they are rarely used. Answer. Correct answer. A. Explanation. Natural refrigerants like coal, ammonia, and hydrocarbons have negligible or diluent, making them environmentally preferable despite challenges such as flammability or high pressure. Their use aligns with sustainability goals and regulations encouraging reduced environmental footprint. Safety precautions are necessary with natural refrigerants due to flammability or toxicity, so ease of handling is an advantage. Synthetic refrigerants often have high diluent, and natural refrigerants are increasingly adopted despite cost or availability. Question 10. When faced with customer concerns about high initial costs of green HVAC solutions, Davis wants to demonstrate cost effectiveness. Which cost-benefit analysis factor is most persuasive in supporting green HVAC adoption? A. The upfront equipment cost only. B. Long-term energy savings and utility incentives. C. The resale value of the building alone. D. The simplicity of installation. Answer. Correct answer. D. Explanation. While simplicity of installation can reduce upfront labor costs, the most persuasive factor in cost-benefit analysis is long-term energy savings combined with available utility rebates and incentives. These reduce lifecycle costs significantly, offsetting initial expenses and appealing to financially savvy customers. Upfront cost alone neglects operational savings, and resale value is more subjective and variable. Demonstrating measurable energy and cost savings aligns with sustainable investment principles. Question 11. During the process of commissioning a newly installed geothermal heat pump system, Mr. Evans notices unusual temperature fluctuations in different zones. What should he check first to ensure optimal system performance? A. Verify refrigerant charge and pressure levels. B. Inspect zoning dampers and thermostat calibration. C. Replace the heat pump compressor immediately. D. Increase the system's set point temperature uniformly. Answer. Correct answer. B. Explanation. Zoning dampers and thermostat calibration directly influence temperature control by regulating airflow to various areas. If dampers malfunction or thermostats are miscalibrated, uneven temperatures will occur despite the heat pump operating correctly. Checking refrigerant charge is important but typically does not cause zone imbalances alone. Replacing the compressor without diagnosis wastes resources. Increasing set temperature indiscriminately doesn't address underlying control issues, risking discomfort and energy waste. Question 12. In light of recent developments in refrigerant regulations, Singh is selecting a refrigerant for a retrofit project aiming to reduce greenhouse gas emissions. Which refrigerant characteristic is most critical for her choice? A. High flammability for better heat transfer. B. Low global warming potential. C. Compatibility with existing compressor oils. D. Ability to operate at high pressure. Answer. Correct answer. C. Explanation. Compatibility with existing compressor oils is crucial in retrofit projects to avoid system damage, leaks, or inefficiency. Even though refrigerants can cause failures if incompatible with oils, negating environmental benefits. While the BU is vital for sustainability, practical operability and reliability cannot be sacrificed. High flammability poses safety risks and must be managed carefully, while high operating pressures may require costly equipment changes, less ideal for retrofits. Question 13. The fundamental question is how Mr. Brown can improve indoor environmental quality in a densely occupied office building while minimizing energy costs. Which strategy would best achieve this? A. Increasing ventilation rates to the maximum allowable by code. B. Utilizing demand-controlled ventilation with co-sensors. C. Installing higher capacity air filters without changing ventilation rates. D. Sealing the building envelope to eliminate all outside air infiltration. Answer. Correct answer. B. Explanation. Demand-controlled ventilation dynamically adjusts fresh air intake based on occupancy measured via CO, maintaining good air quality while reducing unnecessary ventilation energy. Increasing ventilation rates to maximum wastes energy when occupancy is low. Higher capacity filters improve particle removal but don't address ventilation quantity or energy use. Sealing the envelope reduces infiltration but reduces fresh air supply, risking poor EEC, and less balanced ventilation is provided. Question 14. When evaluating the merits of integrating solar thermal energy into an HVAC system, Johnson must consider several factors. Which of the following is the most significant limitation affecting system design? A. The intermittency and variability of solar energy supply. B. The high cost of solar panel installation. C. The complexity of operating solar systems requiring specialist skills. D. The ability to store thermal energy indefinitely without losses. Answer. Correct answer. D. Explanation. Thermal energy storage is inherently limited by heat losses and practical storage capacities, meaning solar thermal energy cannot be stored indefinitely or without efficiency losses. This limitation affects system sizing, backup requirements, and reliability. Intermittency is significant but can be mitigated with storage and controls. Installation costs and operational complexity are challenges but do not impact system design as fundamentally as storage and efficiency. Question 15. To better understand the effects of duct leakage, Mr. Miller conducts a pressure test and finds leakage beyond acceptable limits. What is the primary consequence of duct leakage on HVAC system performance? A. Increased indoor air quality due to fresh air infiltration. B. Reduced system efficiency and uneven space conditioning. C. Lower energy consumption by reducing airflow. D. Improved airflow balance across all zones. Answer. Correct answer. A. Explanation. Duct leakage causes unintended air exchange with the outside, which can introduce fresh air but also contaminants, moisture, and unconditioned air, often degrading indoor air quality. Leakage reduces system efficiency by forcing equipment to work harder to maintain conditions, causing uneven space temperatures. Leakage generally increases energy use, not reduces it, and disrupts airflow balance rather than improving it. Question 16. Several experts suggest that Mr. O'Neill consider building automation system BAS controls to optimize HVAC performance. What is the primary benefit of integrating BAS for energy efficiency? A. BAS allows manual overrides only during business hours. B. BAS enables real-time monitoring and automatic adjustments based on occupancy and environmental conditions. C. BAS eliminates the need for preventive maintenance. D. BAS restricts system operation to fixed schedules without adaptation. Answer. Correct answer. C. Explanation. The primary benefit of BAS is its ability to continuously monitor and automatically adjust HVAC operation in response to changing occupancy, temperature, and other factors, optimizing energy use and comfort. Manual overrides and fixed schedules alone don't achieve these benefits. BAS does not eliminate preventive maintenance. It complements it by providing data for better maintenance planning. Question 17. When considering renewable energy integration, Iscato evaluates the use of ground source heat pump set piece for her project. What is a key advantage of JHP systems compared to air source heat pumps? A. Lower initial installation costs. B. Higher coefficient of performance. COP due to stable ground temperatures. C. Easier installation with minimal site disruption. D. Ability to operate without electricity. Answer. Correct answer. B. Explanation. JHP systems benefit from relatively stable underground temperatures year-round, providing higher COPs and improved efficiency compared to air source heat pumps that must contend with fluctuating air temperature. JHPs typically have higher installation costs and require excavation, causing more site disruption. They still require electricity to operate pumps and compressors. Question 18. According to recent studies, Mr. Davis needs to decide on an HVAC preventive maintenance plan for his facility to ensure green performance goals. Which practice most directly contributes to sustained system efficiency? A. Scheduling annual cleaning only. B. Regular filter replacement and core cleaning. C. Deferring maintenance to reduce operational costs. D. Ignoring refrigerant charge levels if system is running. Answer. Correct answer. A. Explanation. Regular filter replacement and core cleaning prevent airflow restrictions and heat transfer inefficiencies, which sustain system performance and energy savings. Scheduling maintenance only annually may not be sufficient for optimal performance. Deferring maintenance leads to efficiency loss and potential system failure. Ignoring refrigerant charge risks reduce capacity and higher energy use. Question 19. Given the circumstances, Ramirez is tasked with designing a ventilation system for a new office building located in a region with highly variable outdoor air quality. She must ensure adequate indoor air quality while optimizing energy efficiency. Which approach best addresses these goals? A. Use a demand-controlled ventilation system combined with high-efficiency particulate air HEPA filtration. B. Maximize outdoor air intake at all times to dilute indoor pollutants. C. Rely solely on natural ventilation by operable windows. D. Install a ventilation system without filtration but with constant airflow rates. Answer. Correct answer. A. Explanation. Demand-controlled ventilation modulates fresh air intake based on occupancy or pollutant levels, reducing energy wasted on conditioning unnecessary outdoor air. Combining this with HEPA filtration effectively removes particulate contaminants when outdoor air quality is poor, ensuring a healthy indoor environment. Maximizing outdoor air intake constantly increases energy use and can introduce pollutants. Ventilation alone is unreliable and uncontrollable. Ventilation without filtration fails to address harmful particulates, risking occupant health and EEC. Question 20. From a practical standpoint, HRConquer must select refrigerants for new HVACR system in facility prioritizing environmental sustainability and regulatory compliance. Which refrigerant characteristic is most important to ensure long-term sustainability? A. Low global warming potential combined with zero ozone depletion potential. B. High operating pressure for better system efficiency. C. High thermal conductivity regardless of environmental impact. D. Compatibility with older system components without considering environmental factors. Answer. Correct answer. C. Explanation. Selecting refrigerants with diddly and zero op is essential to comply with environmental regulations and reduce climate impact, making this the primary sustainability factor. High operating pressures may improve efficiency but pose safety and cost challenges. Thermal conductivity affects system performance but does not guarantee environmental sustainability alone. Compatibility with old components is important, but should not override environmental priorities. The best refrigerants balance performance and environmental impact. Question 21. During the commissioning phase of a high-efficiency variable refrigerant flow (ERF) system, Chen notices that certain zones fail to maintain set point temperatures consistently. Which troubleshooting step should she prioritize? A. Verify refrigerant flow rates to each indoor unit and inspect for blockages or leaks. B. Increase the overall system capacity without zone-specific adjustments. C. Replace all thermostats in the building simultaneously. D. Disable the building automation system controls temporarily. Answer. Correct answer. B. Explanation. ERF systems rely on precise refrigerant flow control to individual zones. Verifying flow rates and ensuring no blockages or leaks is crucial to resolving temperature inconsistencies. Simply increasing system capacity ignores underlying flow issues and wastes energy. Replacing thermostats without diagnosis is inefficient. Disabling automation removes control benefits and can worsen performance. Targeted diagnosis and adjustment ensure optimal system function. Question 22. The growing trend in green building emphasizes minimizing water usage in HVAC systems. Is the new and must choose a cooling tower designed for a commercial facility? Which design feature best supports water conservation while maintaining thermal performance? A. Incorporating a closed-loop system with evaporative cooling. B. Using an open-loop cooling tower with high drift losses. C. Selecting standard open-loop towers without water treatment. D. Ignoring water conservation in favor of low initial costs. Answer. Correct answer. A. Explanation. Closed-loop systems reduce water consumption by circulating fluid within a closed circuit, minimizing evaporation and drift losses. Combining this with evaporative cooling maintains efficiency while conserving water, essential in sustainability goals. Open-loop towers with high drift lose significant water and require chemical treatment to avoid scaling and corrosion. Neglecting water conservation undermines green building principles despite initial cost savings. Question 23. Several experts suggest that Mr. Patel should optimize the duct design to reduce energy consumption in a large industrial HVAC system. Which principle will most effectively improve duct efficiency? A. Minimize static pressure losses by reducing unnecessary duct turns and ensuring smooth transitions. B. Use smaller ducts than calculated to increase air velocity and reduce fan energy. C. Select duct materials based on lowest upfront cost regardless of surface roughness. D. Increase duct length to avoid sharp bends. Answer. Correct answer. D. Explanation. Minimizing static pressure losses by reducing sharp bends and transitions is fundamental to duct efficiency, reducing fan power consumption. Using smaller ducts raises air velocity, increasing friction losses and noise. Material selection affects longevity and roughness, impacting pressure loss. Its cheapest materials often degrade faster. Increasing duct length usually increases pressure loss and energy use. Efficient layout of a necessary lay. Question 24. In response to tightening environmental regulations, is retrofitting an existing HVAC system with refrigerants that have a lower environmental impact. Which factor is most critical to ensure system reliability during this transition? A. Ensuring compatibility of new refrigerants with existing system oils and materials. B. Choosing refrigerants based solely on load debut values. C. Avoiding all refrigerants that require changes to compressors. D. Prioritizing refrigerant cost above all else. Answer. Correct answer. A. Explanation. Compatibility with existing oils, seals, and materials is essential to prevent leaks, system failure, and safety hazards during refrigerant retrofit. Be important, but incompatibility negates benefits by causing operational issues. Some newer refrigerants require component changes to operate safely and efficiently. Avoiding this outright can limit options. Cost is a factor, but secondary to system and performance. Question 25. While evaluating energy efficiency principles, Mr. Lewis considers implementing demand-controlled ventilation (DCV) at a conference center. What is the most significant advantage of DCV in this context? A. It reduces energy use by adjusting ventilation based on occupancy levels. B. It guarantees zero outdoor air intake to save energy. C. It increases system complexity without clear benefits. D. It eliminates the need for filtration systems. Answer. Correct answer. A. Explanation. DCV dynamically adjusts fresh air based on occupancy or co-concentration, reducing heating, cooling, and fan energy by avoiding overventilation. Zero outdoor air intake is unsafe and non-compliant. With DCV adds some system complexity, benefits in energy savings and comfort outweigh. Filtration remains necessary regardless of ventilation control to maintain air quality. Question 26. Taking into account system design and installation best practices, is Walker sizing HVAC equipment for a mixed-use building? What is the most important consideration to avoid oversizing? A. Conduct accurate load calculations considering peak and diversity factors. B. Selecting the largest available unit for future expansion. C. Ignoring envelope insulation values during sizing. D. Using standard equipment sizes regardless of building specifics. Answer. Correct answer. C. Explanation. Accurate load calculations that include peak demand, diversity, and envelope performance ensure equipment meets but does not exceed requirements, preventing inefficiency and short cycling. Oversizing by defaulting to the largest unit wastes energy and increases wear. Ignoring insulation underestimates efficiency gains and can lead to oversizing. Standard sizing ignores unique building loads, compromising system performance. Question 27. Considering the evidence, Mr. Simmons is tasked with choosing between a heat recovery ventilator (HRV) and an energy recovery ventilator (ERV) for a cold climate. Which system is generally preferred and why? ERV because it transfers both sensible and latent heat, improve in humidity control. HRV because it only transfers sensible heat, which is sufficient in cold climates. C. Neither because natural ventilation is preferable in all climates. D. ERV because it requires no maintenance. Answer. Correct answer. B. Explanation. In cold, dry climates, HVACs are preferred since transferring latent heat. Moisture is less critical and could add unwanted humidity. HVACs recover sensible heat efficiently, reducing heating loads while maintaining indoor air quality. ERVs are more suitable in mixed or humid climates. Natural ventilation is uncontrolled and inefficient in cold climates. Both HVACs and ERVs require maintenance to remain effective. Question 20. While examining the consequences of integrating renewable energy into HVAC systems, Mr. Ellis is considering a solar-assisted heat pump. What is the primary challenge he must address to ensure reliable year-round operation? A. Managing the variability of solar energy during cloudy or winter days. B. The high initial cost compared to conventional heat pumps. C. The limited availability of solar panels in urban areas. D. Difficulty in installing solar collectors on flat roofs. Answer. Correct answer. A. Explanation. Solar-assisted heat pumps depend heavily on solar energy, which is inherently variable due to weather and seasonal changes. Ensuring reliable operation requires designing backup heating systems or thermal storage to compensate during low solar gain periods. Although cost and installation challenges exist, they are secondary to maintaining consistent thermal output. Urban solar availability and roof type are site-specific but do not universally limit operation. Question 29. In the modern context of HVAC system commissioning, Wallace observes that after balancing, some zones still experience poor airflow and temperature inconsistency. What should be her first course of action? A. Recheck and adjust balancing dampers and airflow measurements in problematic zones. B. Increase the overall system fan speed to force more airflow. C. Replace all air filters immediately. D. Ignore the issues since minor fluctuations are normal. Answer. Correct answer. A. Explanation. Proper airflow balancing is critical to ensuring even temperature distribution and occupant comfort. Rechecking and adjusting dampers and airflow verifies that design flow rates are achieved in each zone. Simply increasing fan speed can waste energy and create noise without fixing imbalances. Replacing filters may help if clogged, but is not the primary step after balancing. Ignoring issues risks occupant discomfort, system inefficiency. Question 30. During the process of retrofitting an existing HVAC system, Alvarez encounters a situation where the building envelope has been significantly upgraded with improved insulation and air sealing. How should this impact her approach to HVAC system sizing and design? A. Reduce equipment capacity to match the decreased heating and cooling loads. B. Maintain original equipment sizing to ensure future proofing. C. Increase ventilation rates to compensate for reduced infiltration. D. Ignore changes to the envelope as they have minimal impact on system sizing. Answer. Correct answer. A. Explanation. Upgrading the building envelope with better insulation and air sealing lowers heating and cooling loads by reducing heat transfer and infiltration. Proper HVAC design principles require resizing equipment to match these reduced loads, improving energy efficiency and reducing short cycling risks. Maintaining original sizing results in oversizing, leading to higher energy use and where increasing ventilation is necessary. Should be balanced with load reduction, not arbitrarily increased. Ignoring envelope improvements overlooks critical efficiency opportunities.